Hi everyone, we are from Team AnyPay. The track that we want to tackle is track 1, financial inclusion, especially in the field of offline payment. Can you imagine one day you came to a new places which will make any transaction to purchase the thing you want, but then there is no internet connection and you don't bring any cash at all. So what can you do? Here comes our problem statement. The first one, dead zone area everywhere. As you can see at the right side of our slide, there's a diagram show where is the dead zone without internet connection. Second, merchant revenue loss from cashless customer. So those don't come with cash, they might not be the merchant customer at poor internet connection places. Third, user fear overspending offline because they are afraid that the balance is not synced real time and they might overspend. Fourth, no safe offline alternative provided by Touch and Go currently. Here comes our solutions. There's three main steps. For the first one, they will have two category of user. So for the new user, they will only have a fixed offline spending limit. For those user with history, they will get a smart limit based on their spending pattern. We use the lightweight machine learning model on this. And second, make payment. So the payment can be done through two type of NFC and token generated. Third, there will be a sync when online. So when two of these devices go online, the transaction will be uploaded to cloud and settled once they are online. Here is our impact and benefit. For the first one, financial inclusion. Of course, we want to enable cash payment without internet. Second, merchant growth, because there is no lost sales due to the connectivity issue. Third, TNG revenue expansion, because this can increase the total transaction volume by expanding user base to those who live in rural area.
We extended Touch and Go Wallet with three things. First is NFC. It enables offline peer-to-peer payments by allowing two phones to tap and exchange a secure token along with device credentials, ensuring that every transaction is verified and came from a legitimate person. We also have a lightweight AI model that runs entirely on device to assign user a safe offline wallet balance. For the Alibaba Cloud Tech site, we use Table Store to store the wallets, balances, and user data, and their linked device key and credentials for verification and offline amount update after the payment went online. In AWS Tech site, we implement DynamoDB, runs the settlement ledgers, store tokens records, and implement machine learning pipeline with SageMaker to generate lightweight training model.
So how is machine learning model being generated and why are we using it in our system? First of all, it starts from the AWS S3 object storage, which is used to store the user's transaction data and also in order to get the user's behavior pattern. So we use those data sets to fit into the SageMaker machine learning pipeline in order to generate the XGBoost train model. But the XGBoost train model are not enough to run on a user's mobile device and also offline environment. So we have to use the three Lite tools to convert the XGBoost train model into the TensorFlow Lite model. The TensorFlow Lite model are able to functions to estimate a more flexible and personalized safe offline balance.
So now we're gonna demo our offline payment, how it works. So for example, this is a seller and this is buyer. So when the Touch and Go is online, it will have a mode. So I will just demo toggle here. So this is the offline mode. So as a seller, if he purchased a nasi lemak with me that costs 5 ringgit, so I can request 5 ringgit from him. Request, and at this stage, I need to scan the NFC with his device. So I scan. So in this NFC, actually I have passed the AID token that recognizes this is a Touch and Go token and also the PUB, my device PUB. So at this point, the buyer can confirm the payment. So they can check the amount, is it 5 ringgit, and then the buyer can confirm. After buyer confirm, it will require buyer to perform the face recognition, and then the buyer need to perform the second NFC scan. Alright. So in this second NFC scan, the buyer had passed the signed JWS token and also AID token to the seller. So done. We can see the amount authorized and also encrypted token here. This is only shown for the demo purpose, showing what's inside the token, but this will not show in the implementation of real world.